All right, now we have an example where a massive ball hits a lighter ball that is initially at rest. Last time we had kind of the opposite. A lighter ball was hitting a more massive ball that was initially at rest, and we saw that the lighter ball bounced off. Is the more massive ball also going to bounce off in this case, or does the mass make a difference there? And I'm going to do this with the center of mass approach again, but I would definitely encourage you, if you don't like that approach, or even just to do it, because it's good to know how to plug into formulas correctly and get all the minus signs and stuff correct. Good to get some practice with that. Is if you want to on your own, try using the one-dimensional elastic collision formulas and see if you get the same result. So I will draw this, though. I always do a little drawing just to make sure that everything makes sense. And with more experience, you also kind of know what to expect a bit more. And that's partly we're trying to build that, I think, here by looking at these two different scenarios of what we expect to happen. Like in particular, this question about whether it bounces off, I think is part of the experience building here. So anyways, okay, we have, that's the situation. This one's at rest, right? So there's no initial velocity there. I'm going to start by finding the center of mass velocity, which would be 400 times 6 meters per second. And we already know that one contributes nothing, right, because it's at rest. So we'll divide by the 600 grams, though. Okay, so that is like, let's see, that's 400 over 600 is like, oops, if I put grams there, I better put it there too. Oh, well, normally I don't, right, but I put them in there. It's okay. That's 2/3, though, right? So 2/3 of 6, oh my goodness, I'm getting tired. I think that's 4 meters per second. If you struggle with that kind of stuff, join the club. Yeah. Anyways, 4 meters per second is the center of mass velocity. So again, following this process with the center of mass velocity, I'm going to find the initial velocities in the center of mass frame, which means I subtract that from the two things I'm given. 6 minus 4 is 2 meters per second for the initial velocity in the moving center of mass frame, or just moving frame is fine by me, if you want to call it that. That's going to be minus 4, because it's really like 0 minus 4, right? Because it started at rest. So minus 4 meters per second, and that means that the final velocities, you just switch the signs on these. It's sometimes easy to get confused with this notation, so that's why I've done it in the last, I'm doing it in a couple examples, like pretty systematically the same, so that you can see a good example of how to do that. If you want to change notation, I guess maybe that wouldn't be the worst thing, but do be careful, maybe I'll say. Anyway, last step is I'm going to add back the center of mass velocity. So minus 2 plus 4, I think, is 2 meters per second. And for the final velocity for the 200 gram object, which is V2, 4 meters per second plus 4 meters per second is 8 meters per second. And maybe just a final check to make sure I didn't make a mistake somewhere, is the difference in the initial velocities I was given was 6, and the difference between these two is 6 as well. So that most likely means I've done it correctly. It's maybe conceivable that maybe there's some really weird situation where that check would actually fail. But anyways, it's definitely one I like to do just to make sure, because sometimes it does catch my mistake. Anyway, so I think this answers the question, but returning kind of to the conceptual question of, like, I asked, would we expect this one to bounce off like we did or saw in the last example where it was 200 grams hitting 400 grams as opposed to 400 grams being launched at 200 grams? And I think the answer is no, it doesn't bounce off. It merely slows down, because this 2 meters per second implies that this object that I've called object number 1, or M1, is still moving to the right at a reduced speed of 2 meters per second after the collision takes place, and a bunch of momentum was transferred, so the 200 gram object really got a pretty large final velocity as a result of that transference of momentum. And that makes sense because it's a relatively lighter object at half the mass of the object that hit it, so it's going to speed up quite a bit as a result of that transferred momentum. Let's go ahead and check these numbers, though. Looks like everything checked out.